Hello. So I may have accidentally deleted the video I just did, which was writing uniform variables on the shaders and making our project 3D. So I'm going to quickly go over everything. Yeah, I'm really sorry about this. Very silly of me. And the best thing about it is obviously I saved the project and I didn't back it up. So yeah, we're just going to do it this way. So what did we do first? First of all, we made the triangle a pyramid instead. So it's just going to quickly draw that out and explain how it works. Because we've got index draws, just going to draw the z-axis blue. So we're going to number these vertices like they are in the indices, and then draw it out so that it makes sense when we go through it. So position 0 is minus 0.5 on the x, 0, 0 on the y and the z. So that'll be here. We'll name that position 0. The second one is positive on the x and nothing else, so we'll just do that here, number 1. The next one is positive on the z on the y and nothing else, so we'll do that here, number 2. And yeah, that looks like a 2. And the last one is positive on the z-axis, which would be over here, but I'm going to do it the opposite way because you need to be able to see what's going on. And then we're basically drawing each point to make up the pyramid. So 0, 3, 2 is, oh, I didn't actually number this one, 0, 3, 2, and then it finishes itself off when it draws. The best drawing in the world, I know. 2, 3, 1 is basically drawing like this, 2, 3, 1. On the back, 1, 0, 2, we'll change it to red to kind of show that it's on the back. What it is going 1, 0, 2, and then finally we have the bottom face, which is 0, 3, 1, which we'll do pink. The bottom of it is a pink, 0, 3, 1, and then it finishes itself off because it's drawing triangles. So that's the way this works. I'll show you what it does. We've also added some movement, I think. Oh, I think we did that in the video before, actually. I keep saying we. It's just me. Just me. You guys didn't get to see the video, so yeah, we should probably have a moment of silence for that video. It's very sad. What else did we do? So this is basically just utilizing our create object function. Oh, and when you create the object, don't forget to put in the number of vertices, sorry, this one's vertices, and the number of indices, which is just 12 and 12 at the moment. So what's nice is we don't have to repeat ourselves when we're drawing this thing, because you imagine 2 gets used this many times, position 2 gets used that many times, and when you're drawing with arrays rather than indices, that means that every single time you draw this point, you're drawing you're drawing it 3 times basically, just to make this pyramid, and that's just a waste of memory. When it's indexed like this, it's like just having a list, and you're pointing to each point in that list. That's what's useful about drawing this way. Otherwise, we've got to do this value so many times. Anyway, enough about that. We also created the projection and the view so that we're actually looking at things in 3D. When you haven't got the projection and the view set up with Opengl and you run, you don't have any depth. If I was to, let's add, where are you? Model. So if time fun, that was that time thing. So if I was to add that to the z-axis as well, I probably should do something like 0.0 add the minus time fun. Although it might, maybe it should be -1 because it's probably going to go through the camera. Let's see what happens. Oh. But if you imagine if we didn't have this projection set up, which I can literally just take out by going into the shader, if I take out projection and model, then what we'll have instead is something that doesn't look quite correct because it's not getting any smaller or anything whilst it goes down the z-axis. So what we've got, I'll tell you what, let's Google perspective versus orthographic. This is what's happening. Okay, so when you haven't got when you haven't got the perspective matrix set up with a field of view, you only get a box, and everything looks the same size no matter what the distance is. Whereas when you've got a view, you have, you know, the field of view, you've got the box growing as things get away from you, making everything appear smaller. There's another example. It's pretty good. I hope that makes sense. So yeah, we'll put that back in. And we'll go through the projection and view setup. So, because we're using GLM, it's very nice and easy to set up the perspective and the view matrix. So we'll do the projection first. So we've got a function called GLL perspective, and what this does is take the field of view that you want, the aspect ratio of the window you're using, and the near plane and the far plane. So maybe I shouldn't have closed off that little. I'll tell you what, let's open it up again. Was it Shift Control T to do? Yeah, there we go. So the near plane is this one. It says it there, near clip plane, far plane. There. Yeah, that makes sense. So that's the positions of these two. It's saying the distance from the camera. Yeah. And then we set up the look at thing, which is basically just telling Opengl where to look. This is useful because you can pass into here stuff to rotate the camera and everything like that. So when you've got a camera class set up, you probably be using this to calculate the forward direction the player is looking, or the camera is looking, the up direction so that it's not skewing or rotating incorrectly, and the direction that it's looking. Okay. So what this is look at is, first of all, we've got the position of the camera. So this is just -1. We've got the you could really easily implement some functions here just to update the X and the Z axis, for example, for forward and backwards. Use binding like plus and minus to like the arrow keys or something. You know what I mean? I mean, I'm not explaining that very well, but yeah, that's how easy it is to set up the camera now. GLM Vec 3. This one is the direction that you're facing, and this one is the direction of up. Okay, so we're facing the Z, positive on the Z axis, and the up direction is positive on the Y axis. So exactly like the sky over your head. Okay. And then once we've set those up, we have to pass them into the shader so the shader can actually use the data. So we do that by creating uniform variables. Like we had uniform model in the first time we used a uniform variable, uniform projection, and uniform view. What does uniform actually mean? Well, if you imagine when you're doing uniform scaling of an object and it just doubles in size, you can imagine that it's just instantly doubling in size. But if you were to do that, and uniform just basically means that it's scaling the same amount of scale on every single axis. So uniform just means that it's the same for everything that gets passed through the shader. This data is going to be the same. Whereas when you're passing in data to the shader using the vertex attribute pointer, you're doing it per vertex. Okay, I hope that makes sense. So for example, all the data that comes in from Vec 3, which is what we've got for our objects, that's going to be different. Whereas for model, projection, and view, this information is going to be the same for every single vertex that gets passed in here. I hope that makes sense. And we basically use them to multiply things by them. So in this video, I'll demonstrate with a fun little thing to make, just because we didn't get, well, you guys missed the other video that I made that actually goes for it. So to set up the uniform variables, we make an address like we did with the shader ID, with the VAO, that kind of stuff, GLUN, and we're making an address. And this information here in the main, let's just call it the main project, global. There we go. Is just duplicates from the shader. In the shader, we have the same thing: GLUN shader ID. Well, actually, we're not using that part, but uniform model, uniform projection, uniform view, and we're getting these values later on down in the while loop. So uniform model equals shader get uniform model. So we're just getting this information from the shader class, and the shader is getting the shader class is getting the information from the shader. Okay. So get uniform model is just returning these values. Now where do we assign these values so that they get their addresses? In the compile shader function. So, oops, sorry. Let's go to the shader.cpp, and in the compile program, after you've linked the data, linked the shaders and everything, we start assigning the locations of this information on the shader. So uniform model equals get uniform location, shader ID, and model view projection. These are the uniform variables that we've put in the shader. Okay. And what I should have done in the video, really, because I did have a bit of a problem with uniform view, because I didn't set it up properly, is do this. So printf, and we want uniform model location equals, and we just put in %I think, because it's an int. It's an unsigned int, isn't it? I'm sure it'll be fine. And that, and that'll get us. Come on, type. Still didn't get it right. There we go. That'll get us the location on the GPU of where this is stored. So we'll do the same thing for uniform view, uniform projection, and quickly run it so you can see what that does, because it's really handy. If any of these values are ever -1, it means it can't find it. So we've got 0, 2, and 1. I probably should have done. This is always something I forget. Just quickly put backslash there, not on the end of these, because then it means new line, nice and easy. And then it'll be tidy. Go over to this. There you go. See, location 0, location 2, location 1, and that's just getting where the information is stored on the GPU. I think I thought that they were used in the order that they were printed in the order they were used, but it doesn't look like they are. They just tends to find them in any order it wants. And I have a feeling that if you don't use one of these variables, then no, it still manages to find them. Right. Anyway, so after we've done this bit, we've got the process to get the information from the shader. We also want to be able to assign information to the shader for uniform model, uniform view, and uniform projection. So, like we did in the first video where we got this one, we also did the same. Well, I also did the same thing for the uniform projection and the uniform view. Just passing the data in with the projection that we've got up here and the view that we've got here. Okay. I hope that makes sense. I didn't really go through it very well, but what we're going to do now is demonstrate it with a nice, fun piece of code. Let's hope. So let's make another uniform value, and you can see how annoying it is. Uniform space silly. That's what I'm going to call it. That's our new fun piece of fun. So inside the shader.h, which I've closed because I'm an idiot, there it is. We want another uniform value called uniform space silly. I'm going to duplicate the get uniform view. We'll just change that to uniform space silly, return uniform space silly, and then in the shader.cpp we need to also get the location. So uniform space silly equals get uniform location space silly, and we'll do the same thing again. So uniform space silly, yeah, and then in the shader.vert we're going to have another uniform. This one though is going to be a float of called space silly, and then we also need to go down to the main. Go down here, uniform space silly equals shader1 dot get uniform space silly, And then we need to assign it. So we go. We haven't actually assigned. Okay. Right. Come on, think. So GL uniform 1F because it's one value of a float. If you were to put in a vector, for example, a vector of 3 floats, then you put in 3, and you have to put in each piece of the vector separately. So 1F location is uniform space silly, and the float will be space silly transform, which we haven't made yet. Space silly transform is going to be similar to the time fun thing, only. Oh, actually, I could just make it a time fun thing. What do you reckon? Oh well, let's just see what happens. I have no idea what's going to happen. I've just kind of thought I need to demonstrate it, so I'll demonstrate it using this. Okay, so in the shader.vert, we've got uniform space silly. What are we going to do with it? Well, do you remember me saying we can't update the position because we passed it in as a GL static draw, so this information can't be played with. So instead, let's make a new vec4. So vec4 new pos equals just think how to do this. Vec4 pos dot x pos dot y pos dot z, but z I want no x actually. I want to times by space silly. Oh, and then we want 1.0 at the end because it's a vec4 and this is only a vec3. And our space silly is only a float. Did I pass it in as a? Yeah, this is right. Sorry, my bad. Let's see what happens. I don't know what's going to happen. Okay. Well, nothing's happening. Okay. What we got? Uniform space silly location equals -1. Do you remember what I was saying about -1? It means it can't find it. Uniform float space silly. Space silly. What have I done wrong then? This is a lowercase s, is it? No. Let's just copy this entirely. Sometimes it can be -1 if it's not being used. I should probably stop it going out of the screen, but let's quickly stop that from happening and then we can have a nice look. So we'll go back by 2 positions rather than, well, you know, the size of 2. It's still going out of the screen. Let's go back by 3 then. Right, the uniform space silly thing. What's going wrong? Time space silly. See, I haven't seen anything misbehave like this before. I'm just running it again thinking something's going to change, but I don't think it is. Location equals 0. It's got to be something to do with the way the uniform is set. Can it be a uniform float? Should be able to be. Uniform float scale. What have I got? Uniform float space silly. So what? Why isn't it liking it? Is it because when I'm assigning, no, I won't do that. So when the shader gets created, and it comes up, goes through the shader.cpp, space silly. Let's change it to a vector of vec3, and we'll change it here as well. So space silly. Where are we assigning it? There. So uniform 3f, and we need to also change the space silly transform. Wait, did I not create the space silly transform? No, it's there. What? Right, GLM vec3 space silly transform equals, and we want GLM vec3. We want 1 and 0 on the, so we're multiplying by that, and then the time fun will be the last thing that goes in. That should be a float, and then dot x basically transform dot y dot z. So we're passing in the vector 3 now instead of the of a float, and that means I can literally just say down here times pos times space silly. I might need to put these in brackets, I don't know. Just finding the space silly transform now, so, and timing is probably not. Let's change the time fun slightly, because that's so we'll put time fun b equals that times 2 or 3, so it's 3 times faster basically. We'll see what it's actually doing. Maybe we should rotate it as well. What is going on? Where's the rotate? GLM rotate. Oh, rotate. Model. GLM vec3, and we want to rotate it by. What should we rotate it by? Tell you what though, I don't want it to be moving out the z-axis. So, oh, that's not the vec3, that's the angle. The angle we want is. Do I still have that angle variable? I do. Right. So don't want to rotate them by the x. The y, yeah, go on then. By 5, 0.5, and then by 0, 1, 2, 5. There. Let's see what happens. We just got a mess, haven't we? Oh look, the point on the triangle is just going through itself constantly. That's very funny. It's impossible to see because of the silly rotation on it. Anyway, you can see the kind of fun you can have with uniform variables. I'm quite surprised the float thing didn't work. Pretty sure it's usually alright. I mean, I pass in a float on another function, so it must have just been the way I was using it. Potentially with the position data, you know. Let's see, what was it? What was it before? It was new pos times it by space silly. That's why I didn't put the new pos here. So if I go back into here and go back to the point where we change this from a, there we go. So it's a 1f. I don't know if this is going to work straight away, but we'll find out. Yeah, it's finding uniform space silly now. It's because it wasn't being used in the shader that it didn't find it. And my guess is it's like ignoring it. Wow, this looks weird. Let's rotate that by 90 degrees because I bet that looks. Well, we'll rotate it by QM, rotate, model, GLM. Oh no, angle is just we'll put angle. GLM, vec3, 0.25 on the F, on the Y even, and then 0.12 on the Z. It's just their percentages of how much you want it to rotate on that angle, kind of thing. I wish it would rotate slower. I could change it. It looks so weird. Oh look, you can see it's almost like it's eating something. It looks very silly. I'll tell you what might look interesting if we were to change this to. We change this back to pos, the pos thing, which is that one. Nope. And then we'll have the vertex color, which I think is an out vec3, so we don't need to change it to that. So be just pos, be a vec3, pos.x times space silly, and then these two close. We can get rid of this one now. Let's see what happens now, because it should be changing the color of the. We'll see what happens. I can't tell if it's changing color because I'm just rotating it so fast. What about if we times all of it by space silly? So I was going from black to red there, and well, yeah. I'm just kind of demonstrating what you can do. This isn't a great demonstration, to be honest. I should probably just turn off this rotate because it might be driving some of you mad. And the translate. It's translating. What's it translating? Y and Z as well. Let's change that to 0. Now it'll be a bit less horrible to look at. Too much going on at once was what it was. Yeah, so you got a fun little pyramid just changing colours. Gives you an idea of the kind of control you have now though. So if you wanted to pass something in to change the colours, or you could even change the there was a tutorial that I was looking at that was to make waves using the vertex array. So you could technically make this triangle wave have waves going up at the side, like I don't know how to describe it, but you can do it much more than what I've done, basically. Just takes a bit of time, doesn't it? Fuck me, half an hour. Well, this these videos haven't gone as great as I want them to, and they are taking up a lot of time now. So I'm going to be, I'm probably going to be quiet for a while until I can come up with a better way of giving this information out, because these videos I jumble over my words, you know, and I'm not editing them. They're all in one take. So it's not really the best way of learning. I feel like it should be a bit more structured. So in the future, when I've got a bit more time, I'll remake this entire thing and be a bit more structured. We'll stick to the whole a fast version and a really long-winded one like we're doing at the moment. Only I'll put more time into these ones to give a real good explanation of what's going on and where we're doing what. And it should help with any of you that are having problems with like trying to find out what errors are happening and how they're happening. Like, for example, if I didn't have this projection here, what happens? We have nothing on screen. And do you remember what I was saying about them not being able to find the projection? Well, apparently projection location is 0 because we printed it out to the thing. But if you imagine, we wouldn't have that if we haven't gone to this section here to print that information anyway. So technically you'd be like, why isn't there any projection, or why is it not working? And you might find that one of your uniform variables are just missing from this list. So it's a good idea to have the list, because then you can find any problems that you're having. But I think this will do for now. But I hope you've taken something away from this, at least. I mean, I've put a bit of effort in, not as much as I'd like to be honest. If I'm completely honest, I would love to just kind of be able to dedicate myself to this, but I've only started this Tuesday. What is it now? Friday. So 3 days and made a tutorial on building a project with shaders. I don't know if that's a good accomplishment or not, to be honest. Usually it takes me about a day to write everything from scratch, but I've only been doing this since August, and it's now October, so it does take a little bit of time to get an understanding, but it's worth it. When I first started and I was seeing all this stuff, it's kind of like well, it's alien, isn't it? It's like reading a language you don't understand, and the only way you can understand it is by playing with it and figuring out what's going wrong, googling the errors you're having. That's important. Google any errors you're having. Like if you're trying to draw and you're getting a black screen with no errors coming up, then it's really difficult to understand where the problem is. And my advice, if you're getting something like that, is to try and strip out as much as you can, strip out the shaders and see what is going on, because it might be if it's a problem with your draw function, then your shaders will have nothing to do with it. If you're trying to play with the shaders to understand if it's the shaders that are causing the problem, then you're not going to find where the origin of the what do you call that? The origin of the problem. So for example, if I was to GL use program 0, basically telling the shader not to be used here, see what happens. I was hoping I'd just get like a triangle drawn, but apparently not. You'd have to strip it out manually. Anyway, fault finding is probably one of the hardest parts of coding, but it's really worth it because you get a good understanding of what's going on. So yeah. Anyway, cheerio.